Hey everyone, and welcome. Today, we are diving into a really cool tool from the world of AI, the AOI algorithm. Now, this thing is designed to solve some seriously complex problems, and we're going to break down exactly how it pulls it off. So, let me ask you something. How do you solve a problem that just feels impossible? Well, the secret isn't always about just grinding harder. A lot of the time, it's about being smarter in how you even approach the problem in the first place. Okay, so here's what we've got on top. We'll start with the big idea of solving those impossible problems. Then we'll get into a unique way of looking at choices, the whole and/or thing. That'll lead us right to the star of the show, the AO star algorithm. We'll see how it's different from its more famous cousin A star, watch it in action with an example, and then zoom out to see the bigger picture. Sound good? Let's jump in. All right, first things first, let's talk about the core strategy. You know, when a problem is just way too big to even think about, the absolute best thing you can do is chop it up. And there's a name for this. It's called problem decomposition. It's a super simple but really powerful idea. You can solve the whole puzzle by just solving each of the little pieces. And this concept? It's the bedrock that algorithms like AO star are built on. Okay, so you've broken the problem down. Great. But now you need a way to, map out all those new mini problems and the choices you have. And that brings us to a really special kind of decision map. Let's make this super simple. Imagine your goal is to pass a big exam. How could you pull that off? There are a couple of ways you could go about it, right? So you've got a choice. Path 1 is an OR path. It's simple. You could just cheat, one action, and bam, goal achieved. But then there's the AND path. This one's different. You have to do the hard work and you have to pass the exam. See how both are required? That's why we link them with that little arc. It's called a hyperedge, and it's just a visual signal that these two things are a package deal. You gotta do both. And this whole structure, it's called an and/or graph. It's a special kind of map that's absolutely perfect for problems where you have these forks in the road, your ORs, and some of those roads require you to complete a whole set of tasks, your ANDs. So, with a complex map like this, how on earth do you find your way through it to get to a solution? Well, that's where our main tool for today comes into play. The AO algorithm is what we call an informed search technique. What does that mean? It means it's not just stumbling around the map in the dark. It's smart. It uses something called heuristic values, which you can just think of as educated guesses or cost estimates, to constantly figure out which path looks like the best bet to get to the finish line. And this is where we get to a really important distinction. See, when you're looking for a solution, there's a huge difference between finding the absolute best one and just finding one that works. This is where the AO algorithm really shows its true colors. You've probably heard of the A-star algorithm. It's pretty famous, and for good reason. A-star guarantees it will find the single best, most optimal solution possible. It will search high and low to make sure of it. But AO-star? It plays a different game. Its goal is just to find a solution path, any viable path. And once it finds one, it stops. Its job is done. It makes absolutely no promise that the path it found is the cheapest or the fastest one out there. So this is the main takeaway, the thing you have to remember. AO does not explore all the solution paths once it got a solution. The second it finds one complete path from start to finish, it just stops. It doesn't double back to check if there was a better way it could have gone. And this is a deliberate trade-off, right? It's choosing speed and finding a solution over the guarantee of finding the perfect solution. Think about a robot trying to get around an obstacle. A pretty good path right now is way better than a perfect path that takes forever to figure out. All right, that's enough theory. Theory is great, but let's actually see this thing work. We're going to walk through a super simple example to see exactly how the AO star algorithm thinks and makes its choices. Okay, so check out our problem graph. We're at the start, A, and we have two choices. We can take the AND path, which means we have to go through both B and C, or we can take the R path straight to D. Now, the algorithm uses its heuristic function, its best guess, to estimate the cost of each option. The guess for the B and C path is 20, but the guess for the D path is way lower, only 11. So what's it going to do? Naturally, it's going to check out that cheaper-looking path first. So it follows that initial hunch, explores the path through D, and, yep, it confirms it can get to a solution that way. And the final cost is exactly what it guessed, 11. As far as the algorithm is concerned, it did its job. It found a complete path from the start to the end. And this right here perfectly shows you the algorithm's core personality. It found a solution. Game over. For the AO algorithm, the mission is accomplished. It stops right there.
But wait a second. We're watching this from the outside, right? So we can ask a pretty important question. Was that really the best path? Is a cost of 11 really the lowest we could have gone?
So let's just imagine, let's play out the what if. What if the algorithm didn't stop? What if it went back and explored that other path through B and C, the one that looked more expensive at first? Now here's the cool part. As an algorithm actually travels down a path, it's no longer guessing. It gets real information. And this new info lets it update its original estimates, making them way more accurate.
And would you look at that? After it actually explores that other path, the new, updated, more accurate cost turns out to be just 7. That is a much better solution. But the algorithm completely missed it. Why? Because it found that good enough solution of 11 first and just stopped looking. This is that trade-off, live in action.
Okay, so let's zoom back out. What does all this mean in the grand scheme of things? We've gone over some pretty detailed stuff, so let's boil it all down to the key things you need to remember.
All right, so here's the cheat sheet. First, we saw that any massive problem gets a whole lot easier if you just break it down. That's problem decomposition. Second, we learned that and/or graphs are the perfect way to draw a map of those new, smaller choices. Third, we met the AO star algorithm, which is the special tool we use to find a path through that map. And finally, and this is the big one, we figured out its whole philosophy. Find a solution that works and find it fast. It's not hunting for the perfect one.
And that really leaves us with one final thought, doesn't it? The AO algorithm is all about making a very deliberate choice. It picks speed over perfection. And that brings up a really interesting question that goes way beyond just code and computers. In our own lives, when we're making decisions, when is good enough actually better than spending forever searching for perfect? Something to think about. Thanks for tuning in.